Welcome everyone to this month's core community call. Today we have for discussion light clients, and we have the Tiny Answer team, Anushk and Hirsch, talking about different ways that they have been thinking about implementing it. The agenda can be found as usual on the core community call repository, and the specific SIMD is 52 that I have just added to the chat. Anushk, if you're welcome to take it away.
Yeah, thanks for the intro, Jacob. Let me just share my screen. Yeah, thanks everyone for joining and giving your time. I'm Anush from the Tiny Dance team, and we've been working on implementing the light client for Solana. We drafted SIMD 0052 for adding transaction proof verification. So today we're going to give a brief overview of our research on it. So I'd like to start with why we're doing this. The motivation behind this MD is primarily to implement light clients for Solana. The reason we need light clients is because users need to verify queries that they make to the RPC. And right now they cannot do that, which is why they have to trust the RPC that they give them the correct data. These light clients need to be low hardware pieces of software, and they need to be able to run on a phone or browser. So this is really important for security of a blockchain network. As we already know, more mature networks like Ethereum that have been there for longer already have light clients, and this was a glaring problem in Solana. So the crux of this SIMD is adding something called transaction proof. So on a high level, it's just a Merkle proof saying that your transaction that you sent was included in the block, and it succeeded or failed, however it should have. The change that we're making here requires some way of making sure that a particular signature and a status, whether it's success or failure, was included in that transaction in the block. The user needs to be able to verify the inclusion of the transaction and the execution status. We would also add a RPC method that would allow anyone to just call that method and get a proof for the particular transaction. So as I mentioned, for the reason that we need this is because RPCs could give you incorrect information that the transaction actually succeeded or it was included in the block, but it actually didn't, and that's an attack vector. We can still verify this data if you have a snapshot, but obviously snapshots are 30-40 gigabits, and that's a lot of data for the everyday user. Also relating to a different SIMD about stake weight attestations, you can actually use transaction proofs to verify that a particular validator has a certain stake off chain. As mentioned in the SPV proposal, a validator could technically use transaction proofs to use them as like a checkpoint to verify a certain state. And as part of a different proposal that uses SPV, it can also be used for interchain verification. Here's a list of important resources that you could take a look at. This is the SIMD that we wrote, the SPV proposal. There's an open issue that talks about adding statuses to the bank hash. and that's the interchain SPV proposal. So this is the part that we really there's been a lot of discussion on, and we think that there needs to be more discussion on from different parts of the code of community on like different ways to implement it. In our SIMD right now, we are really implementing the first way, which is modifying the block hash to include statuses. But over the last week, after discussing with uh, some members of the Jump team and uh, other members of Solana Labs, uh, we also found different ways to implement it to tackle different issues that may arise while implementing the first method, that is modifying the block hash. So I'm going to dive into each of these very briefly. So modifying the block hash is pretty straightforward, and again, part of the SV proposal. So all it does is you add the transaction status along with the transaction signature into the Merkle tree of the transactions, which is part of each entry. And that gets hashed that gets Merkleized into the block hash and becomes part of the bank hash. Currently, the block hash is a sequential hash of all the entries, but making it a Merkle tree would be better in terms of verification size. And obviously having the status is important for verifying if a transaction actually succeeded. Here's a quick overview of the pros and cons. So the pros being that on the client side, the verification is less computationally heavy, so that's good for low hardware devices, and it's part of the core consensus protocol, which means that all validators have to agree to it. Yeah. The downside of this being that it's quite a major change and would require feature flag activation, which means that the round trip from implementing this to actually going live on mainnet would be quite long. And also there is a computational overhead of Merkleizing entries that also needs to be taken into account. Moving on to the second method, which is adding a separate transaction tree, which would basically be a tree of all the receipts of each transaction. This would be part of the bank hash. So basically just a Merkle tree of all these transaction signatures and statuses, and would just be hashed into the bank hash. The pros of this are mainly that it doesn't come the way of bankless leaders. So a leader could basically just create the entries, create the block, propagate the block, and then asynchronously update the bank hash with the statuses. So they don't need to have it before propagating the block. Again, this is also a major change. So comes with the challenges of the first way to implement it. Yeah. So this is part of the second method, which is we were told that implementing changing the bank hash would somehow come in the way of bankless leaders. So if we implement this, which is basically have the state of block n in block n plus 10, you actually don't need to execute the transactions of block n to get the statuses, and then have compute the bank hash. So you could just do that in a sort of async way. But this also would be a pretty major change to the consensus protocol, and that is also something that needs to be heavily considered if you're deciding to go with this. The last one is probably the most flexible and easy to work with, because we are not really changing any core part of the validator like the consensus. So we are just using gossip, or could be a different network even, to just asynchronously push a Merkle commitment of all the transaction receipts. And this could be done, like, let's say, every 10 blocks or so. So, it's not even doing it every block. And you could then have validators that pull this change, verify it against their own state, and then push an attestation saying that, hey, this checks out with the data that I have. Now, a light client could just, pull that data, pull those attestations, and just verify if X% of the stake has actually confirmed that this is the correct hash and that their transaction was included in that. The pros of this is that there's no overhead to block production, because done asynchronously, it's not part of the block hash. There's low risk of liveness failures because it's not part of the core consensus protocol. And it's also easier to implement because it's part of gossip and not consensus. The only downside would be that it's not baked into the core protocol, so it would be optional to implement, and the validators aren't really forced to make those attestations or commitments. So this is where we end this presentation, and want to hear more about the thoughts of the core dev community, and open to any critiques or questions. Thank you.
Go ahead, Richie.
Hey, so I'd just say thanks a lot for working on this. I think this is a really nice initiative, and it seems like a rather easy win, complexity, and wise for enabling this functionality. I would just like to voice my preference for going the gossip route, any related method of doing it this way, where we don't modify the core data structures to support this feature. I think my main problem with modifying the proof of history hash would be that it's a quite breaking change of the definition what the proof of history hash currently is, where it would basically go from committing to the block data contents of the current block and all blocks before that, to going to committing to the state changes that this block induces. And this would matter for fired answer, for example, because we might use the POH hash to identify the chain that fired answer and Solana Labs are currently on. And let's say, for example, we have a temporary mismatch in the runtime where we derive a slightly different state on both clients. By redefining the proof of history hash to potentially differ on both clients, I think it would be much harder to tolerate such runtime mismatches or even detect them, as that would basically stop firedance from synchronizing entirely, rather than continuing replay with a slightly different state. And similarly, I think going the forced delay route doesn't seem too elegant to me, because that would basically introduce minimum latency for any light client, where they would need to wait these n blocks, be it 10 or so. I think regardless which way we choose, maybe I thought of splitting up the proposal into a few separate SIMDs, and then it would be much easier to vote on each one specifically, because it feels like if we try to incorporate this entire feature into one, there's going to be a bit of discussion on it for quite a while. So the first one that I thought of would be just agreeing on how we actually compute the commitment for the transaction statuses only. So, given a vector of transaction statuses, what goes into the hash? So do we just commit the transaction result code, or do we also hash logs in some way, and then define what the actual root of the transaction statuses is? And then we can do a separate SIMD that says, here's how you would propagate it over gossip. And then we might go back and say, well, in hindsight, gossip was a bad idea. So here's another SIMD of how we would propagate the transaction statuses or whatever other protocol. One other way would be, of course, posting it on chain itself, which of course has the benefit that this kind of incentivizes validators to actually participate in this transaction status calculation. Whereas if I wanted to be mean, I could say, hey, I don't want to implement this feature in Firedancer, so I'm not just gonna propagate it over gossip, which would, I think, decrease the quality of service. So I think we kind of want to incentivize validators to participate in this feature. Again, thank you so much. I'd love to hear your thoughts and on these. I'm also gonna post the same feedback on the SIMD itself.
Likewise, I also respect your interest in this, indeed. I think that gossip is definitely a favorable route because it allows us to test a lot of the client UX of the elect client, and because it's actually simpler and less of a breaking change. It's easier to revert back if we messed up, if we think that's not the right way, then doing that from, making a change to the bank hash and then thinking that, okay, this is not the right way and going back to gossip. And I think that regarding validators being incentivized to participate in the network, that's something that can eventually be figured out and might even be another someday. I think we can, I'm leaning more towards what Richard said with going with gossip.
Well, yeah, I totally agree regarding the incentivization. I'd be also curious whether Solana Labs has any thoughts on this proposal. But be really cool to see progress moving on this rather soon.
I just want to say, first of all, it's really good effort. It's gonna help a lot, I think, to the community. One of the issues I saw regarding the transaction status is we've generally been moving away from detailed transaction statuses more into very broad categories of failure. And the reason for that is, so for example, originally, we even had the runtime errors as part of the consensus. Luckily, that's not the case anymore. So there's now only one error case for the entire runtime in the consensus. And the reason why we move away from that is that the success cases are already complex, but the failure modes are so much more complex. And it really, really narrows down the implementation you can have to get the exact precise error response of every transaction right. And that makes it almost impossible to change anything or to re-implement it any other way. So yeah, just be careful about transaction results. Don't include too much error state or logging into them. Otherwise, we will all be stuck with exactly one implementation.
Yeah, so we really just wanted to include success or failure. There was a suggestion to include transaction logs, but we can actually avoid that by just re-executing the transaction on the client side by fetching the inputs. But so we just want success or failure.
Yeah,
I heard
good.
some feedback suggesting that we also add logs. I think logs are pretty scary because right now the truncation of logs is not well defined. But maybe that's actually an opportunity to say that there's a recommendation to, for example, only do 256 byte long log lines. The concern I had there was how this would affect performance if we hash 2 or more SHA blocks for each program execution or so. Would that limit the TPS in the future? I don't remember who it was. I think it was Mango. Yeah, I don't know.
I think the only concern was like with the overhead added by logs, but I think you mentioned that uh, with fire answers like implementation of SHA, I think that might not be a problem.
W, you have your hand raised. Go ahead and start.
Yeah, no, I just wanted to clarify, Richard, when you actually for both Richard and Anushk, when you say the gossip route, you mean that there are going to be no consensus changes, right? Like even whatever the validators are voting on regarding the state or whatever state is necessary would be in like a separate smart contract. It wouldn't be part of the block.
Yes, correct. It wouldn't even be in a smart contract. You'd basically just, so there's a structure called
Something
contact
local.
info.
Okay.
Yeah, so the contact info is a structure that every validator publishes regularly onto Gossip. As far as I know, there's already a snapshot hash and an accounts hash. So it seems like it would be fairly trivial to fit in another hash there. So there's actually a bit more discussion around whether we should have an entirely separate hash for this. Because usually if you're getting the transaction status commitments, you probably also want the accounts hashes. And the problem with doing separate fields for this is that you'd basically have all validators sign them separately. But I think if we fit them all into the same contact info block, that might not be a problem.
They also don't need to be at the same frequency, right? How frequently is this contact info updated? Or how frequently do validators publish it?
That'd be a question for Solana Labs, I think.
I mean, that's an implementation detail anyway, but I just wanted to be clear that in the gossip route, there are no consensus changes, right? So even the transaction status or anything, the block structure doesn't really change. So Tiny Dancer won't be blocked in any way on that, right?
Yes.
Okay. Yeah, just wanted to clarify that.
Okay, are there any other questions for Anushk and Hirsch? Carol, I think you mentioned that the Mango they suggested using bidirectional connection. Max, I think you're here. Did you want to speak a little bit more on that?
Sorry, could you repeat? On which one should I speak?
Kirill mentioned that y'all suggested to use like bidirectional connection. I believe this was originally like a experimental feature that y'all are implementing on the labs client, and it's like a client specific. Did y'all want to? Okay, Kirill says it might not be relevant anymore.
Yeah, I can give some background still for the people who are interested. So what we did is when we run benchmarks on a local network, we'll enable a patch on the TPU side to give us back basically a status. Like it's just a very short status that summarizes what happened with the transaction in the scheduler. This is very similar to I would say like request tracing environment that you would see in a commercial microservice architecture deployed in a private company. Send something in from a load balancer, right? You want to trace for a limited amount of the requests in the network why they're not getting scheduled, right? So you get a per request measurement that is actually complete, because right now the measurements we have are statistical and broad, and it's very hard to say in particular which transaction, like we just see, oh, 5 out of 100 transactions had this issue, right? But we don't know what's wrong with these 5 transactions. Why didn't they get into the block, right? What were the 5 transactions that hit the CU limit, or what were the 5 transactions that hit the, I don't know, 2,000 packets per 10 per 100 milliseconds on a quick connection, right? There's different limits in the stack, and it's very hard to identify why a certain transaction didn't pass. That was the original intention there. But yeah, I think there's a lot of pushback against this kind of, I would say, nice to have feature. We really enjoyed having it for like local performance testing because we get more insights. But yeah, that's it.
Good, Richie.
I've looked at this a bit, and it wouldn't seem that hard to support in Firedancer or Solana Labs, and I think it'd also be pretty nice to have for clients to get explicit feedback about why the transaction might fail or not. And it seems like in financial kind of applications that would seem like a basic feature to have, especially if they're user facing. Like if I go in my wallet and send a transaction, and that gets dropped somewhere along the path, since this is a issue that would seem to directly affect the user experience of our client. I think it would make sense to report that, but it requires a bit of plumbing to get that data back to the networking layer, because usually at the point of where you know where your transaction gets dropped, you probably already anonymized the traffic flows where you don't have the IP addresses or quick connections anymore. So I feel like there should be, I don't see why we wouldn't move to bidirectional connections just to have the ability to do this kind of reversible feedback in the future. And then we could just maybe publish this in the specifying what the protocol should be for reverse flow feedback. And then, you know, I think as time goes on, we'd see more Solana Labs clients adopt this and Firedancer clients. What was the specific feedback why this wouldn't be a good idea?
I think there's a couple of like performance questions there, right? So I think the main issue is that it kind of like creates risk on the security DDoS protection side. So
I think I know where this is going. So currently every transaction is a separate unidirectional stream, and after you send it, it gets closed. So if there's reversal feedback, maybe that can force the client to keep open these streams for longer by just saying, hey, I dropped these packets, please send them to me again. But that should be easy to fix by, for example, delivering this feedback with datagrams or with, you know, a persistent stream. I still don't really see why we shouldn't do it if this data is easily available. I see Galactus from Mango raises up. Yeah, sorry.
Yeah, so actually, like what we implemented is more like you have this like with Solana client, we cannot really implement this bidirectional stuff because once you get the like connection, it's dropped immediately after reading. So what we implemented is a separate service where like a validator, a validator can connect, and then it can say like list of transactions that it wants like feedback for, and so actually like whatever is executed, like for X reason is dropped, then we just send the like why it was dropped actually. So it's more like a separate service. It's not in the same, even in the same like TPU client, TPU server.
I see. I mean, it would seem a bit cleaner to just deliver acknowledgements after.
Of course. Yeah, of
directly,
course.
yeah.
Yeah, I also love, like, I would also like to have like a bidirectional channel where you just send a transaction and get a feedback like why it was dropped. But yeah, like on this validator side, there are like a lot of limits, and connection can be dropped for like a lot of reasons, and it was quite impossible just to keep the connection up. So we said like, okay, forget, we'll just have a new separate service. But yeah, of course, I agree. Like we can have this bidirectional connection of Quick, and then we'll just get a feedback for our transaction.
I think if we install a mechanism to signal optional features in the Quick handshake itself, it should be pretty easy to trial out features like this on a real cluster without affecting reliability too much, or without introducing breaking changes. But it seems like it needs a bit more time on finding out what the actual right protocol is for delivering this feedback.
Yeah, I agree. Yeah, because yeah, Quick right now, like we don't have like a lot of bits remaining just to have like give accurate acknowledgement, I think, while closing, or even in the acknowledgement packets. Yeah, maybe we have to find maybe another some another mechanism to get this acknowledgement. I agree with you.
All right, we're a few minutes over time, so I think what we'll have to do is we'll have to continue the discussion, probably open up the PR that's on this, as well as the discussion on Anush's the SIMD 52 earlier. But thank you all for coming this month, and I'll see you all next month for the next SIMD call. Reminder, if you have any agenda items, make sure you do a PR to the next agenda so that we get it earlier rather than later, and people can read any additional information beforehand so we have a better discussion. But thank you.